Good afternoon, everyone, and welcome to my project-based lesson overview on a little bit of what I have to share in the way of the project-based lesson itself in terms of content, but just as importantly, in follow-up to that quick review, more of an emphasis on all the tie-ins that I found with this assignment with respect to EDTPA, EdTPA. I found it to be very resourceful, and I never would have thought that there would be that much emphasis put on some of the key underlying messages that we're sending to our students until I got into this assignment. And well, for starters, my name is Steve O'Neill. This is with respect to, again, the PBL presentation for Dr. Taylor's CTE-5660 class. I enjoyed this project very much. It was near and dear to my heart because coming out of a manufacturing engineering background, I was able to take what amounted to a project that spanned over a week's worth of time just in material coverage and build on previously learned lessons in this class. There were a number of surprises along the way, I must say, but as much of a positive, surprises, with respect to surprises came out of this as much as any negative. But again, the EdTPA message was loud and clear in the end in terms of how to assess my performance as well as the students moving forward when you look to modify this lesson. But again, for starters, I just wanted to quickly go over what I covered in my lesson plans with this project. I covered the class out of Trade and Industrial Education called Drafting 3 Engineering, or IV23 section number. This lesson covered really 2 modules and then some. 5.0, which you see highlighted here, apply procedures to create working drawings, and then beyond that, apply procedures to create a professional portfolio. This is akin to what I like to tie into an honors project, but it can be used at this level of Engineering 3 on multiple project-based assignments. The specifics of 5.0 and 8.0 are as such. 5.0 forces you down the path to where you have to apply procedures to create working drawings of a 3D model and assembly, and that's strictly out of Autodesk Inventor here. And whereas as part of the curriculum, it's strictly design-based to include assembly drawings, detailed drawings, and a parts list. Beyond that, the drawings need to be annotated, dimensioned, and multi-view projected. I added these 3 highlighted items to include a little bit of a manufacturing slant on this project. Because again, given that manufacturing my background, I thought it would be a good opportunity to do so. All that did was kind of supplement the required curriculum content with a little bit of bonus material. And the sections that I covered with 5.0 involved sections that would have addressed component annotation and layout of multiple views, like what you see here in this simple pin, as well as this simple cylinder rod support. And all these annotation notes and dimension concepts were previously learned, but now we're applying it on a drawing sheet in Inventor, a whole other software package. And then finally, to include that of an assembly where you have a parts list made up of a table and a couple of ballooned items that indicate those items down here as items 1 and 2. I show you this just because this is a sampling. This is a real basic sampling of a pin, a rod support, and a rod assembly that includes both those items. That was the extent of the curriculum until I decided to add the bill of order of operations, manufacturing process plan, and a control plan, just to give this thing some much needed, I felt, bonus material for sake of being able to have the students figure out exactly what the order of operations are going to be in building this thing, as well as what our costs are. I won't get into the weeds on that one, other than to say that the bill order of operations, the manufacturing process flow, and the control plan are all an assortment of Microsoft Office docs, whether it be, spreadsheet, Word, or PowerPoint, and they're straightforward enough to work out of their respective software packages, but there's a little bit to coming up with the procedures necessary in order to figure out how things flow in a manufacturing environment. But I felt it was necessary to add it to this section, and then finally we went further to include a professional portfolio. Now, I included their videos that instructed my students on all three aspects to these sections. One was 5.0, Introducing Working Drawings in Autodesk Inventor. That's a clip that preceded that of the manufacturing docs that I spoke of a moment ago that support the drawings in Autodesk Inventor. And then finally, the introduction to creating a professional portfolio. These three videos pretty much captured the three lesson plans that I crafted for this project-based lesson. One was in support of introduction of working drawings in Autodesk, a 1 to 2 day, or actually a 2-day lesson plan that basically broke out those three sections, 5.01, 2, and 3, in a way in which we were starting to address these concepts towards a Formula One fully assembled car. And the way that took life was with a couple of picture drawings that carried over from the earlier lesson. If you look, I have a Formula One car with 2 students at the tube. This is a partner-based activity. But before we even got into the Formula One car in Autodesk Inventor, the students were required to come up with a sketch solution to what they wanted in the tube. This shows the entire design cycle, and I thought it was beneficial to have them sketch out what they wanted before we actually went further with it in development. From there is when we started to look at lessons that incorporated our 3 major components. Again, that being 5.01, 2, and 3 with respect to creating our working drawings. And then from there, our supplemental material to include the control plan, BOM, BOO, and MPF. And then finally, the methods in which we would create a digital portfolio to include not only the presentation, rendered image, and animated assemblies, but how to pull all that into an electronic portfolio to include a resume. Actually, with this F1 car, we actually went further to round out the presentation in a way in which we included a website. And that was an option. The students could have used a PowerPoint presentation to show their design life cycle of their car, or they could have used the website. Many of them did exactly that, chose the website. But this is about, more than anything else, personal branding and being able to apply everything that they've learned in such a way where they're comfortable enough to present it in a way in which they're selling their idea of their design and build, as well as revealing it. That was my project-based lesson in general, speaking to those 3 lesson outlines. And in the end, what they did is they came away with a Formula One car design. Now, what I had never considered before that I was really happy to include this time around was just how much of an important aspect there was to tying this into EdTPA. I found the focus to be probably the most beneficial in that I was able to come away with student objectives that leaned heavily on what we had previously learned. For example, I showed you the picture earlier of the students working on their sketch of their Formula One car. This is what provided the motivation for us to move forward with our lessons in Autodesk Inventor and manufacturing documentation to build it. Because without this motivation and coming up with their own personal design, it would have been a hard sell to go beyond the drawings to include that of the manufacturing docs, which determined how much these assemblies were going to cost and how they were going to be made. I really thought that the present and past relevance in the way of prerequisites and requisite information and going into this class project were huge. And I had never really spent that much time concentrating on that until EdTPA came into the fold with this lesson. And then probably the most important aspect for me was how the EdTPA assignment forced me to differentiate, not only by way of the types of learners that I had in this class. And by the way, I only had about 13 students in the end, and with the exception of one female student and the rest being male, I didn't really have any classroom challenges, but I did come across, and I was very observant to, based on this EdTPA initiative, the various types of learners that I had. So where I didn't have IEPs or 504s to concern myself with, I did have different types of learners that revealed themselves over the course of the project. So that made a big difference in how I was going to pair students up and what the expectations would be in the end. And then finally, how I would differentiate based on those learning constraints, if you will, amongst the students. And most importantly, I think in the end, how I would modify this lesson moving forward. I think EdTPA does a very nice job of forcing us into just that, making adjustments based on all that documentation that we've compiled over the life of this project-based lesson, and helping us to ascertain exactly based on the metrics that we've been able to compile, how we're going to make this lesson even better and more robust the next time. That's pretty much what I have in the way of a wrap up on this project-based lesson presentation overview. It was a very worthwhile project in that it not only taught me to think outside the box with respect to how well I could challenge these students, but also, you know, how well I could apply professional pedigree to a lesson that required, you know, a great deal of reflection in the process. I hope you enjoyed this presentation, and by all means, please let me know with your comments moving forward. Thank you and have a great night.